For the next test, we're going to show the UPS's capability of providing stable output voltage with one of the output phases at 0% load. The other two output phases fully loaded, or as close as we can get in the test simulation we can do today. So let's take a look at this. So the UPS is operating with the converter on inverter, batteries connected, all 5 power modules operating. So it's a 2 megawatt 9900D UPS. But let's take a look at the output. So currently on the output, we have a stable output voltage, but our output currents on phase A and B are about 2,100 amps. Our current on phase C is 0. So completely unbalanced load on the UPS. So you can see that we have about 1 megawatt output, 1154 kVA, 0.86 power factor, and 1 load failure. Let's take a look at the output voltage waveform on our AMEC units to see how this actually looks on the output of the UPS. So we come over here, we have our input power showing 1 megawatt coming into the UPS, our output voltage on the output of the UPS, a slightly elevated C phase. But let's take a look at the current on the output of the unit. So the currents as shown, 2136 amps and 2065 amps on phase B, and phase C just has a little bit of residual current, but truly operating fully on 2 phases with 0 on the 3rd phase. There is no specific criteria on this test, just to show that the UPS can perform operation on a fully unbalanced load. Similarly, what would happen in your facility if, say, you lost one phase of a breaker, or someone completely loaded up only 2 phases off of all the UPS output in your site, completely unbalancing that load. And really, the UPS maintains stable operation even in that event, allowing you the time to rebalance your loads and not have to worry about what the UPS can and can't do during that situation. We really appreciate you watching this video, and if there's any questions, feel free to reach out to us and we can provide more detailed discussion on any of the topics you saw today.